Hello everybody, and welcome to exercise 4 on page 142 of the workbook. And here's an example of where we're going to be calculating some partial derivatives and trying to make sense out of them graphically. Okay, so let's read this question together. They're giving us a function that looks like 1/2 y e to the negative x over 2. We're looking at a graph of that function over here to the right. And the first part of this problem, in part A, is asking us to use the graph to rank a list of quantities in order. Okay, and the thing to remember is that each of these 5 numbers, we want to think of those as being slopes. They represent derivatives. Okay, so we want to use the graph to help us figure out what the relationship between those slopes are. And you might notice that there are a couple of points involved. There's a 3, 2 that appears a couple of times, and there's a 1, 2. Let's see if we can find those points on our graph just to get started here. So 3, 2 would be where x is 3 and y is 2. So we'd be moving 3 in the x direction and 2 in the y, and we'd come to here. Okay, and then 1, 2 would be up here. 1 in the x direction, 2 in the y direction. Okay, just so we can see where we're talking about. Okay, let me just get rid of some of the markings that we have here. And now one by one, let's think about those 5 numbers on the list and see if we can rank them. Okay, so maybe starting with fx at 3, 2. Okay, that's like asking us for the slope of our graph in the x direction at the point 3, 2. So we're here. And so if you imagine drawing a tangent line in the x direction, first thing you can ask yourself is, does it look like we're going up or down? And remember, the x direction is going this way, kind of in the same direction that the x-axis does. Okay, to me it looks like we're going down. If we were like a bowling ball on the surface and we started up here and move in this direction, we're sort of going down. Okay, and then what about at 1, 2? Same question. Okay, if we move through this point, does it look like we're going up or down in this direction? Okay, to me it looks like we're going down. Now, where are we going down the steepest? Okay, would you say that at 1, 2 up here, or at 3, 2 down here? Okay, if you look carefully at the graph, it looks like we're a little bit steeper up here at the 1, 2 point. So that means we should get a slope that's more negative at that point. Okay, so that tells me that this fx at 1, 2, that's going to be the smaller of those 2 negative numbers. Okay, so maybe just to help us conceptually here, what we're saying is that fx 1, 2, we're getting the steepest negative slope there. At that point 1, 2 in our picture, we're going down really fast in the x direction. Okay, so those 2 numbers are negative. Then we're going to come to the number 0. Okay, a slope of 0 is kind of in between positive and negative numbers. All right, and let's get rid of some of the markings that we made here. And now we're going to move on to the slopes in the y direction at those 2 points. Okay, so at 3, 2, if you were kind of a bug on this surface and moving in the y direction, you'd be going like this. Does it look like we're going up or down when we do that? Looks to me like the surface is getting a little bit bigger as we move to the right. And then what about at 3, 2, 1, 2? Same question. Notice that we're going up. The z-values are getting bigger. And where does it look like we're the steepest? Up here at 1, 2 or down here at 3, 2? To me, it looks like we're going up a little bit faster up here at 1, 2. So that tells me that fy at 3, 2 is a positive number, but it's not as big as fy at 1, 2 is. Okay, so fy at 1, 2 is the steepest positive slope. All right, so if we're thinking about that correctly, this should be our answer to part A. There are our quantities ranked from steepest negative to steepest positive in order. Okay, so we're ready for part B. And part B is asking us just to algebraically confirm the answers that we got to part A. We have an order that we think is correct in part A. Let's actually calculate those 4 partial derivatives and see if our order is correct. All right, so we need to start with the function we were given. Let's remind ourselves of what that was. So fxy looked like, okay, I need to scroll up here a minute, 1/2 y e to the negative x over 2. Okay, and we want to take the derivative of that with respect to x and y. Let's start with x. Okay, so if we take the derivative of this function with respect to x, we're looking at that. Notice that the 1/2 y is a constant that we can pull outside, so we'll bring that out. And then we need to take the derivative of e to the negative x over 2 by the chain rule. That's going to be e to the negative x over 2 times the derivative of the exponent. Derivative of negative x over 2 is just negative 1/2. Okay, so if we simplify that a little bit, that's negative 1/4 y e to the negative x over 2. There's a formula for the derivative in the x direction. Okay, let's do the same thing in the y direction. Oh, and actually, hang on a second. Let me correct a notation error that I made here. Up here, we were taking the derivative with respect to x, not y. So that should really be partial x. Okay, now we're ready to take the derivative in the y direction. Okay, and this time, the thing that's constant that we can pull out is the e to the negative x over 2. And my writing's a little sloppy. Let me try that again. So we've got e to the negative x over 2, and we need to multiply that by the derivative of the 1/2 y. That's just going to be 1/2. Okay, and so we get a derivative that looks like 1/2 e to the negative x over 2. Okay, there's our derivative in the y direction. And now what we're going to do is to go back and calculate these 4 derivatives from part A that I'm underlining, okay, and see if our order was correct, okay, one at a time. So let's start with the fx of 1, 2. How would we get a number for that? Well, we have a formula up here for the derivative with respect to x, so we just need to substitute the x and the y into that. Okay, so y is 2 and x is 1. Okay, so we're going to get negative 1/4 times 2 times e to the negative 1 over 2. You can check me. Maybe substitute this into your calculator. You're going to get negative 0.303. Okay, that was the first number on our list. That takes care of the fx of 1, 2. And then what about fx of 3, 2? All right, well, we can calculate that in the same way using the same formula that we have here for fx, just we're plugging in 3 and 2 now. Okay, so we'll plug in 2 for our y and 3 for our x. And this time, if you do that calculation, you're going to get negative 0.112. All right, and we'll do the same thing with the other 2. Okay, let's scroll up a little bit here. So the next 2 derivatives on our list, looking back at the top of the page, are fy at 3, 2 and fy at 1, 2. Let's write those down and calculate them. Okay, and for those 2, we're going to be using our formula for fy that we calculated here. So starting with the 3, 2, if we substitute that in for x and y, our formula for fy just has x's in it. So we're just going to get 1/2 e to the negative x over 2. That's going to be e to the negative 3 over 2. That's going to be 0.112. You can check me on that. And then lastly, fy at 1, 2, we're going to get 1/2 e to the minus 1 over 2. And that is 0.303. Okay, and so what do you think? Does that order agree with the order that we have above? Notice that these are indeed in order. This is the steepest negative, and this is the steepest positive. And all of those numbers are in order from smallest to largest, and that exactly agrees with what we had in part A. Okay, so we'll close this example just by making that comment. So note that the above calculations Okay, agree with the ordering of the derivatives from part A. Okay, and we are done.